Applications of differentiation, a rates of change example. A marketing director of a company found that the revenue, or euros, from selling a fixed number of produced items at p euros each is given by the formula r equals 30p minus 2p squared. Question 1. Find the RDP and explain what this means. So the RDP would be if we differentiate the R equation here in terms of p. So the derivative of 30p is 30, and negative 2p squared we multiply by the power and reduce the power by 1, giving negative 4p. Now we're being asked what this means. So the RDP would be the rate of change of revenue with respect to a change in p. So the RDP gives us an indication of how the revenue would be affected by a change in the selling price. In the second question, we're asked to calculate the RDP when p equals 10. Well, we know the RDP is 30 minus 4p, so we're going to sub the value 10 or 10 euros in for p into this. This is going to give 30 minus 4 tens, or 30 minus 40, which is negative 10. This is just an index, there's no units to this because it's p divided by r, which is euros divided by euros, so it's just an index. So negative 10 is the answer. And the final question is asking us, for what selling prices is the revenue rising? Well, if the revenue is rising, it means that the RDP is going to be positive or greater than 0. Unlike the example there where the selling price was 10, we got a negative answer. So when would we get positive answers for that? So we create the inequality that 30 minus 4p, that's the RDP, is greater than 0. So we add 4p to both sides, giving 30 is greater than 4p. Divide both sides by 4, so 30 over 4, which is 15 over 2, or 7.5, is greater than p. In the context of the question, this means that if p is smaller than 7.5, or 750 euros, and you increase the selling price, it'll have a positive effect on your revenue.